Bismillahirrahmanirrahim. So let's consider another example. I'll consider this system x prime to be ax, where my a is equal to 1 3 1 minus 1. Indeed, it's not hard to show that x prime is x plus 3y and y prime is x minus y for this case. Let's find its eigenvalues first. Eigenvalues. So for eigenvalues, we solve this determinant of a minus lambda I to be equal to 0. So this determinant is going to be determinant of a minus lambda I. So 1 minus lambda 3, 1 minus 1 minus lambda, this is 0. So 1 minus lambda times minus 1 plus lambda minus 3 to be equal to 0. So this is going to be minus 1 plus lambda square minus 3 to be equal to 0. Our lambda is equal to minus plus minus 2. So now let's find eigenvectors for lambda equal to lambda 1. We can find out the eigenvector, and for eigenvector we know that we solve this system a minus lambda 1 I operating on an arbitrary vector xy to be 0 0. So my a was 1 3 1 minus 1 minus lambda 1. Lambda 1 is 2 for this moment, let's say it's 2. So this is 1 0 0 1, and all of this thing operating on to xy to be equal to 0 0. Now this is going to be minus 1 3 1 minus 1 minus 2, which is going to be minus 3, and this is my xy, this is equal to 0 0. From here you can see you will get this equation minus x plus 3y to be 0, or x to be 3 times y. So if you set y to be 1, then x is going to be 3, and in this way your vector v1, which is eigenvector for lambda 1 equal to 2, is going to be 3 comma 1. And in this way x1 is here, which is x of t equal to e to the 2t times 3 1. Okay, so now we will be solving for eigenvector corresponding to lambda to be lambda 2, and which is minus 2. And we again solve this same system a 1 3 1 minus 1 minus lambda 2, which is 2 1 0 0 1, and all of this thing operating on to xy, and this is 0 0. From here you get, so this is 1 plus 2, this is 3 3, and this is going to be 1, and this is also going to be plus 1. So this is xy, this is 0 0. It is not hard to show that x plus y is 0, or you can say that x is minus y. So if you set x to be 1, then y is going to be minus 1. Therefore v2 is going to be 1 minus 1. Hence x2, the other solution, is going to be e to the minus 2t times 1 minus 1. So at the end of the day, what we have done so far, we had this system x prime of t to be ax, with a being 1 3 1 minus 1. We have two solutions, x1 of t to be equal to e to the 2t times, what was eigenvector, it was 3 comma 1 I believe, and x2 of t was equal to e to the minus 2t, and it had 1 minus 1. Okay, recall now, this eigenvalue is positive, and we know that this solution represents a line passing through this vector 3 comma 1. So this is a line which is passing through vector 3 comma 1. and as t goes to infinity, this quantity will explode. In other words, this quantity will go towards infinity, and this way both of these quantities will be moving towards plus infinity. What does this means? This means that this line line through this vector is line through 3 oh, 3 plus 1 is unstable line, or you can call it manifold, unstable manifold for this problem. And don't forget, 0 0 is our fixed point, because for this system 0 0 is always a fixed point. And here as t goes to infinity, or this quantity will get to 0, and in this way the line through 1 minus 1 vector is stable line, or you can call it manifold, stable manifold. So this will be moving to 0 0 as t will go to infinity. Okay, this will be going to 0 0, and this way every trajectory will be moving towards 0 0 along this line through this vector, and any trajectory will be moving away from 0 0 along this line. So first let's have an idea on graph. So let's say this is my y-axis and this is my x-axis. Now we have two vectors, v1 was equal to 3 1. So let me say x-axis, this is 1 2 3, and let's say this is 1. So this is going to be the vector, and line will be moving through this vector, okay, this way. Okay, but this line is unstable, so that means k this way I'll be giving arrows because it's moving away from 0 0. And we have another vector as well, v2, which is 1 minus 1. So my x is 1 and then minus 1 is over here somewhere. So this is my point, this is going to be the vector, and I need a line through this vector. So that's my line through this vector. And don't forget that this line is stable, we have seen, discussed. So the trajectories will be moving towards 0 0. Okay, I'll be putting arrows like this. Now what is happening to other trajectories? Let's see those. If there is another trajectory that is moving along this stable line this way, then it will move away along with this unstable line. Okay, any other trajectory will behave like this, moving towards 0 0 along this, but then will start moving away from this. So forgive me for my crazy drawing. Similarly, because this is stable, so any trajectory that is moving this way along this will be moving away with this unstable. So this way. What about this? It will be like this because it will be moving towards 0 0 along this, and then will start moving away along with this. And for this the behavior will be like this. So again 0 0 is saddle and unstable. I hope it makes a bit sense. Thank you.